Our next speaker is Dustin Freeman. Dustin's background is in math and theater, and he's combined these with works as a spatial interaction engineer at Occipital. And he makes a structure sensor. It's really great. I just had a preview of it, so definitely participate with him afterward in the question and answer. His time when not working, though, is spent creating immersive, interactive theater experiences, and this is what he's talking about today. Please welcome to the stage, Dustin Freeman.
Check, check. I assume everyone can hear me well out there? Fantastic. Okay, let's open this up. So today I'm going to talk about a really practical experience of, like the previous talk, this is really practical, of designing an immersive theater experience around iBeacons, which are a localized beacon which give you a rough measure of how close you are to them if you have a device that can sense them. And this is done through a theater company called FloodLight. This project was by me, Dustin, and the guy on the left, Josh Marx. Now, Josh Marx is all dolled up in this photo because he primarily works as an actor. And when you're an actor, you need to look good. My background is pixels, literally, so that's why my photo looks different. Right now, he's an associate professor of acting at San Jose State. I'm a spatial interaction engineer by day at Occipital in Soma. And I work on computer vision, or at least not on the core of computer vision itself, but on making computer vision usable to hack with. But this project has nothing to do with computer vision. It has a lot to do with immersive theater and improv theater. Now, I'm going to talk a little bit about FloodLight. But I'm not going to spend as much time on the theater philosophy part of this, and I'm going to move right into the practical experience of dealing with a hardware sensor. So FloodLight is primarily Josh's project. He looks at theater experiences that you wander through and interact with, rather than sit and observe passively. The idea is that to be immersive, you should feel like the main character. The agency means you're able to do things and have an effect on the show, and feel that you have an illusion control, even though and the mechanics of the show itself may be really controlled. Another thing that is particularly important is a sense of secrecy or exclusivity, which leads to a sense of intimacy with the show itself. Now, that's some philosophy that I'm just going to put onto the side. I'll get back to later, and deal directly with iBeacons. So iBeacons are a close-range proximity protocol that's defined by Apple. And we got a few iBeacons from a company called Webble who sponsored us. They gave us some iBeacons under the brand XY Find It. So these are the size of these beacons in my hand. If I have a device, in this case I used an iPhone 6, I can ping the iBeacons in a surrounding area and get a sense of how close I am to them. Practically, we got a iPhone to beacon distance of plus or minus 50% within a range of 5 centimeters to 10 meters. So it's not perfect, and the rest of this talk is basically how do you deal with that. Now, in an ideal world, so here's like a really basic thing you could do with this. You could have a bunch of iBeacons in, say, a museum, and instead of having an audio tour where you click through, the audio tour plays at the specific time when you're next to a certain painting. That would be a really basic thing you could do. We want to do something a little bit more interactive where you're able to have an effect on the world at its most basic, kind of a choose-your-own-adventure style experience. One annoying thing we noticed is that if my experience involves me moving objects around, because we can embed these beacons in objects, is that if on the left you see there's two beacons about 1.5 meters apart from the phone, on opposite sides of the phone, so 3 meters apart from each other, and that looks the same to the phone being the god in this sense, or the observer in this sense, that looks the same as them being adjacent. So if we wanted to build a scripting scenario, or a scripted scenario where I bring an object and I put it next to another object, we actually have no idea if someone's done that. Another thing that, did I just go quiet? Okay. Another thing that's related to this is that, let's say I want to do a trigger when someone is looking at something. I never really know if they're looking at something. We don't really get their look vector. They could be walking by something. They could actually be looking in the opposite direction and backing into it. So this entire project was basically how to write software to deal with the uncertainty that the hardware gives us. So this is the layout of a speakeasy. Well, it's called The Speakeasy. It's a bar that we were doing this show in during the day. The bar was nice enough to offer their space to us when it wasn't open. And it was nice because it felt like a real space. It didn't feel like one of those spaces that you set up everything in, and the players that go into the space know that everything that's in the space is there for a specific reason. So they should play through the experience like an RPG player where they grab everything that isn't nailed down. So this bar was fully stocked. There was like booze behind it and everything. We didn't tell people not to drink it, and they didn't, so that's good. So like, let's say you had this in a video game environment, right? And let's say you want to do a scripting experience in a video game environment with objects. And you have areas like the back room or behind the bar, and you could just define like rectangular prism volumes that when the player enters that volume, then you'll start a certain trigger, or you'll move the state of the story to another point, or you'll change some variable. The problem is we don't really know at any given time where the person is. Let's say you put a beacon on the door. From the perspective of the phone, as they hold it with them, you know that they saw the door, and the door went missing. So you don't know if either they backed out of the door, or you just lost the signal for that one particular frame, or they went through. And if you see the door, don't see the door, and then see the door again, they might have gone through and then backed out, or they might be going through slowly and you lost signal briefly, and then you saw the door again and are back inside. Now, hypothetically, you could just double or triple the number of beacons and do some really nice locational triangulation thing, but we only had access to this space for half an hour to set up in. So we wrote this plan down on a piece of paper, brought it home, and printed it off. And what we did is we did something called a Wizard of Oz technique. How many people have heard of the Wizard of Oz technique? Cool, a couple of you. This is really, really nice to prototype how you think something should work without getting your head stuck down in code. So if I went and just coded up what I thought would be a nice scripting system for this environment, I would have all sorts of implicit assumptions of how people would move around, how people would behave, how I would play it if I was playing it right. So what we did is myself and Josh iterated through about 4 different schemes of how we ran the logic of a script. And the way we did that is we would print off this floor plan, and we'd take like a board game piece, and one of us would move the board game piece around, and the other person would act as the Wizard of Oz, as the man behind the curtain, reading the script at what they thought was the correct point. And that's how we prototype behavior. So we wanted to make a live environment that responded to the user. We wanted it to be open. How many people have heard of those like escape the room games? Yeah. So this is a little bit like that. There were objects to find. There were clues to read. But what both of us kind of cared about is not, I mean, I find those experiences a little bit frantic. And you're basically just trying to pound through all the puzzles as quickly as possible. We wanted to make something that was a little bit more relaxed and narrative. We also noticed that there was a little bit of a lag to the beacon detecting you. Like sometimes if you walked by it quickly, like maybe 2 or 3 seconds, so we wanted to encourage people to be slow and contemplative. We wanted there to be compelling choices. We also wanted it to be kind of ambiguous at the end. So I'm going to show you what the start looks like. And this is me playing through with the GoPro. Let's see, how do I get my mouse? Okay, great. So I don't think there's audio for this, but that's fine. So the conceit is you show up at this environment. Josh welcomes you, says he's really busy. This bar is undergoing renovation. He's sending you upstairs to go get this painting and to bring it back down to him. And he gives you this phone, and a headset, and you're supposed to put the earphones in and stick the phone in your pocket. Now, what's cool about the design of this for us is that I work on visual, augmented, and virtual reality during the day. So it was really nice to design something that had nothing to do with like rendering anything. And it was pretty much all audio cues. We got 3 voice actors who are a friend of ours to record a bunch of audio triggers. Maybe there's about 70 in total. And we got people to put it in their front pocket here. Now, big mistake, both of us are men who typically wear pants. And women who showed up would sometimes have pockets that were too small for a phone, or would sometimes wear a skirt. And so they would put the phone behind them in a backpack, or sometimes would hold it in their hand. And since we actually calibrated all the trigger radiuses based on it having be next to your leg, that actually messed up some of our triggers. So make sure you test it in a variety of ways. So after this intro finishes, then you get sent up. And he'd say, I'm going to read instructions, or I'm going to speak instructions to you live. He'd say live as you go through the experience. And he'd pretend that he was a live operator. After a while, you'd realize that clearly these are pre-recorded. So if you memorize the map from before, you'll see that we're entering the door of the speakeasy. There'd be a few options you could go to from here. There'd be clues in audio that would entice you to move toward an object or pick up an object. There was also this on the table on the, let's see. So there's a lamp there that we had a beacon in that'll trigger certain behaviors. In the cash register was also a beacon. And here's just a manifest that had a bunch of clues and extra information. So what was cool about the iBeacons as well is we were actually able to embed them in objects. So Josh sends you up to get this painting for him, and he says it's very important that you go get the painting and ignore any other distractions you see in the room. And so here's this book on this table here, and as you approach the book, it actually starts to whisper at you. Touch the book, touch the book, touch the book, touch the book. And if you come within another radius threshold, it actually begins speaking to you and gives you hints to turn to different pages. So but in this video, you don't see us follow the branch of the book. You just go get the painting and head out. And so what's also nice is I showed you those little hexagonal units that were the iBeacons. You actually could take those apart, and the circuitry inside is pretty small. So we were able to unobtrusively stick them inside the binding of a book, stick them in the back of a painting, and it worked super well. Let me just skip through the rest of this. So here's the layout of all the beacons in the space. And the radius is the approximate trigger threshold. So where the book was, which is here, we had a large threshold that entices you to talk to the book, and then a small threshold, which is where the book starts talking to you. Now, one thing that's interesting, if you're dealing with physical objects, as opposed to a 3D game. In a 3D game environment, you'd absolutely know that everything had happened, and you wouldn't need to be guessing this stuff. With physical objects and sensing, you don't really know what the user is doing, so you have to build your scripting system so that you guess. So we know that the user is close to the book. We fantasized about maybe lining the book with tinfoil so that you know if the user had opened the book or not, and put a beacon inside. That didn't work out. It was too hard that we couldn't reliably do it. So the way the scripting system knew that if you interacted and were chosen to follow the path of the book, is the book would tell you to open it, turn to a certain page, and then bring it, and then on the page would say, go to the couch. Actually, go to this lockbox here. So then we can't just, in the audio, tell people to go to the lockbox, because then that means they might accidentally hear it when they're walking by here, and that just doesn't make sense. The user hasn't shown, or the player hasn't shown that they actually want to follow the path of this particular book. Another thing here that we had to trigger is the lamp on the table here had its own beacon. And the idea is that if you read the manifest here, you'd find that the lamp was magical. It was magic, a magic lamp. Not a wishing lamp, though. And if the painting was actually cursed, and if you brought the painting to the lamp, then you'd purify it and purify the curse. But we had to, initially we had the lamp here, and if you just brought the painting straight out, sometimes the phone, which is the player's viewpoint, would see the lamp and the painting at the same time, and assume that you wanted to purify the painting, when in fact that might not have been the user's intentions. So we had to actually shove the lamp as far away from your exit route as possible. So again, really interesting stuff, really interesting problems we had to deal with that would not be a problem at all in a 3D virtual game environment, but totally are a problem in real space with sensors that are imperfect. So initially, I thought so this is our first draft of the script that we wrote together. There's about 15 pages in a Google Doc that had this kind of rough notion of triggers, like certain things happen when you're closer, certain things will happen when you go out of range. So we wrote this and then agreed on this. And then my assumption as the programmer was to convert this into one or a couple finite state machines. Quickly, it became apparent that that would not work very well because, again, we didn't know where people were at any given time. So I wrote something that spat out HTML so I could look at so I wrote this kind of XML format that spat out HTML so that it was actually readable as a web page, but also I could parse it in a script that would actually run the game. That ended up being kind of clumsy, so I ended up with 2 JSON files. Thanks. On the left defines all the beacons and their IDs and their trigger range. So here, for example, here's the beacon that's built into the painting, and here's this its electronic ID. And here's a book, and here's the book, and we have like an in-range, and then we have a really close range threshold, and these had to be all determined empirically. Empirically, not because perhaps because there's a little bit of antenna variance, but also there's variance in how you'd orient your body towards it, and also variance in when we actually wanted these triggers to go off. So we ran around and walked closer and farther from each of these objects and kind of tested what the right range was. And when we did that, that was actually all for holding the phone like this in our hand and going around and looking at what the range was on each beacon. But then when we played the show, we got people to put the phones in their pocket, which bumps out all the ranges larger. So kind of at the last minute, we actually hard-coded in another script. It's just we add 50% to all of these. So makes you test the same way that you're going to run things. And then, of course, some people actually put the phones in their backpack behind them, so that complicated it even more. So that's the JSON file that described all the beacons and their individual data. On the right is a series of what I call listeners. So instead of having a finite state machine that the script system moved through, we'd have a big list of listeners that could be triggered at any time. So one listener will be triggered by, I see the door. And when I see the door, I can do a couple things. It's most likely play some audio. That's a basic listener will just play some audio. An advanced listener will, well, it also will describe its play style. Like, does it in queue so it doesn't interrupt other playing audio? Or does it interrupt, where it'll interrupt any playing audio and play immediately? So it's kind of like an emergency narration. These listeners would also potentially activate other listeners. Like let's say you've seen the painting, then I can turn all the listeners that the book will say, oh, you've seen the painting, whereas the book wouldn't say that before. So instead of having, this is actually much easier to debug than a big finite state machine. So I have 3 minutes left. I could talk a little bit about player types and personalities in detail. One thing that was interesting is that there's too many people who play escape the rooms, which people who run through things really fast. And I guess for our sake, they were trying to find the best solution, whereas we kept the story kind of ambiguous. and you kind of had to choose who to side with, and there wasn't really a puzzle to solve. It was more of a narrative experience. As for where next, everything was self-contained on the device, and the device didn't actually communicate elsewhere, but you could imagine that the device could communicate to an external server, and it'll turn on lights or sound, or you could have more than one person playing in the same space. One idea that was really interesting is that most smartphones can pretend to be iBeacons themselves. So like, let's say you sent 2 people in on an experience together. You could change the behavior of the system, whether they're close or farther apart. And if they're still wearing headphones, you could send them individual audio. So one thing that I kind of fantasized about was if you're far away from the person, say like 10 meters away from the other person, like you hear whispering in your ear, like conspiratorial whispering. Anyway, if this is interesting to you, Josh is actually going to be mounting a show called The Circle, or based on Dave Eggers' The Circle, which is going to use iBeacons at San Jose State on November 18th and 21st. And you're going to if anyone knows the book The Circle, it's about this dystopian social network that gives you points based on things you do. And so they've rigged up a building with a bunch of iBeacons. And yeah, they've rigged up basically a huge version of the painting with a bunch of iBeacons, and they're going to give you points based on how you wander around this immersive theater space. And that's it.
All right, one more big round of applause for Dustin Freeman. Obviously, he knows what's going on with using iBeacons for tracking things very precisely through this project. He'd love to talk more about that with the question and answer, but he is also that spatial interaction engineer with Occipital, which has a really great 3D camera for tablets and cell phones, so make sure you ask him about them.